a statistical analysis for beginners. So how do you do in that case? Think that you have no any knowledge, but it is needed to apply in your research area. So how do you start? You should know many methods about statistical analysis. Which method is the best fit for your data? I will go steps by steps. Please ignore my words pronunciation because I am not from a native English speaker, and keep in touch with like and subscribe my channel. So let's start here. When do you think about statistical analysis in your research? So basically, when these one, all data need statistical analysis. In all cases, maybe no. Answer, maybe no. Not always needed. So here, what about your data? This is the important. It comes from either experiment in your laboratory, neither in survey. So anyway, see your outcomes. Look your outcomes and try to find out physical meaning of your data. Physical meaning of your data. So over there, if there are any unusual data, that means you think on that way, but your data not on the right track. That means unusual data. Then you should think about different factors. Any factors influence your data. That means factor means here independent variable. So let's see with 3 examples. What is the independent variable? How we know about the variable? So okay. So in example 1, example in Japan, 2 different prefecture, different area, far area with one distance to another distance, with 4 different school students. 4 students in one prefecture. So here is a 2 prefecture, that means totally 8 schools were measured under this study. Okay, 20 students of is graded. In Japan, here is almost fixed 20 students of his classes, and only grade 7 and grade 8 in those 2 classes actually was experimented here. So was actually participating in the study. Duration of experiment was 1 year. After 1 year, again we measured our target value. Each school student have taken the fixed amount of carbohydrate in the lunch time. In Japan here, so lunch time, the school student do that together, lunch. So hypothesis 1, that means assumption. What's our assumption? Carbohydrate, this is the main things, the fixed amount each and every classes. So carbohydrates, that means as rice, bread, like this is the carbohydrate, bean, popcorn and potato, are the main factors these are the main factors to gain the weight of people. That means of a student here. People means here is 8 school student of 2 different grades. Okay, let's see. So here a dependent variable weight. The school student will gain the weight due to the different fixed amount of fixed, that means carbohydrate, different carbohydrate. So independent variable. So dependent variable basically depend on independent variable. Again, dependent variable, the name comes from basically this variable depend on independent variable. Independent variable, that's the decide by researcher. So okay, amount of carbohydrates, that means amount of carbohydrate, this is one of the independent variable. Let's see which type of carbohydrate. Suppose 100 gram, 120 gram, 130 gram. So different type of carbohydrate applied. And grade 2 levels. We know the grade 7 and grade 8 is school, 4 levels. So in one prefecture 4 level is school here. So okay, now we will go to the basically analysis part. So here let's go again before. So here is the main things, the independent variable. So our hypothesis like those independent variables are significantly effects on the weight, which maybe will be gain or loss. So these will actually, we wanna check this one. So let's go here. So amount of carbohydrate here 100 gram assigned for 20 student. That means 2 to 21 is one school. Here is a 20 student. So in grade 7 and 8, after 1 year, this is their weight, and this is their weight, grade 7 and in grade 8. This is the another school where applied 130 gram here. So in this school here in the lunch time provide 130 gram of carbohydrate for one student. So there are after 1 year the gain or loss, those are weight here accumulated. So another school 150 gram carbohydrate provided for 20 students. Another school 170 gram carbohydrates provided for the long of 1 year. Then counting their weight basically. Okay, this is the prefecture 1. So if we would like to know about, here is a weight, so the carbohydrate basically, this is the main factor to gain the weight or loss of 2 grades a student. So let's check this one. We can check this one by using Excel ANOVA analysis. So how we can start from Excel? Those factors actually, this is the independent variable. Again we can see amount of carbohydrates, this is the independent variable, and again amount of carbohydrate for 20 student, that means the different school. So here is a 4 school and here is 2 different grade. So this is the independent variable basically. So amount of carbohydrate, that means 4 types and 2 grades. So here let's check now by using ANOVA analysis. But how? We can start from here. So firstly, here you can go inside the file, and here is option. So you can go into the option. So let's open a new window. So here is add-ins option. Okay, let's check the add-ins. So in the add-in, here is the analysis tool pack. So let's select this one, analysis tool pack. So here is a go option. So go. So analysis tool pack, this one, analysis tool pack. So okay, this one. Now let's check inside the data. So data, here is a data analysis in the right side. So inside the data analysis, we can analyze ANOVA also. ANOVA single factor, ANOVA two factor, and different things. So we will go steps by steps, this one. So here we can see the grade 7 and 8. This is the grade, but two factor. One factor is grade 7, another factor is 8 under the grade. Another carbohydrate, here is 4 levels. That means 4 is equal 4 different carbohydrate level. This is the 4. This is the another factor behind 4 levels. So okay, we will go. So ANOVA, 2 factor with replication analysis and 2 factor without replication analysis. So 2 factor with replication, that means repeatancy. So here we can see the one student, the 100 gram, 100 gram. So repeatancy, that means with replication, again and again same students or different student but same carbohydrate level. In the grade 7 and grade 8, there is no any replication, but here is a replication. If there is a one replication, so we should go 2 factor with replication test. Later we will check also without replication test. So okay, we'll go here. So input range. So which particular area we wanna input? So this is the start particular area, and let's insert the all. Okay, here is it. Select the all here. So rows per sample. Here I have 20 sample. 20 sample. This is the output range. So in the output range, we can start from here. This is the output window. It will come. So analysis done. So here we can see the summarize 100 gram. 100 gram for 20 student. Is a count 2020. There is no any error. So in the 2 grade, here is total 40. So we can see also summarize. Here is a average. This is average and also variance. So here now check which one actually we have important here. So we have important that one, the p value. P value, here is a one sample, another one is column. Column means here is a 2 grade. We can see here again. So column means here is a 2 grade, basically 2 column, and this is the row. So here we can see the column basically first. So column here is a degree of freedom 1, because in column here only 2 grade. So 2 grade degree of freedom, that's one the n minus 1. So 2 grades, that means 2 minus 1, here is a 1. So this is, we can calculate also manually these things, but here is automatically calculated by using ANOVA. So here is a p value. If p value less than 0.05, that means those 2 grade are significantly effects on the weight. 2 grade has a, that means mean value of each classes of 2 grade have a significantly different from each other, and it's significantly affects on the weight. So that's these things. And another things here is a sample, that means the row. So here is a row, degree of freedom 3. How they calculated degree of freedom 3? Because here is a 4 classes. that means 4 is equal. So 4 is equal, that means n minus 1. So here is the degree of freedom 3. So here is also p value also less than 0.05. So this is also significant effects on the different school, that means different mean value. And interaction, there is also interaction. Interaction means here those two things are together interaction effects on the weight. Interaction effects means here is the grade, 2 grade with a school. Here is the interplay, one factor. So interplay one factor, that means here is the another factor behind that. We need further analysis, so we will go later. So in the prefixer 2 here, we can do analysis the same way. That means already selected. And here is also that one. So this is also okay. So we can see here the analysis result. So here is different. The column value is significantly effects on the weight of each classes, and a row value of each school also 0.05. Here is a p value, but interaction effects, there is no any interaction effects. That means this is the greater than 0.05. So there is no any factor or interplay anything else, or more another factor influence on our result. So there is no any influence. So this is the main effects I will describe later. This is the interaction effects. So here uric acid, in that case, so we'll explain here the another example. So the treatment of high uric acid in the blood, basically that's called the gout. This is a big problem in the world. Here in the blood, by using 3 different methods such as generic medicine, that means as usual medicine, then we can buy from a shop. In the treatment 1, that prescribed by doctor. Another one, the generic medicine with control food. As we know, the gout comes from a different food habit also. So in the treatment 2, an apple cider vinegar with baking soda in the treatment 3. This is the another things. This is not these advice are not provided by doctor. So after 1 week of under treatment in all 3 treatment conditions, the amount of uric acid in the blood were again tested. So okay, let's see now the result. The patient, 5 patients here. So treatment 1, the uric acid, the amount of uric acid here in the blood. Treatment 2, after 1 week, then amount of uric acid, that's 1. And treatment 3, the amount of uric acid, that's 1. So here is the uric acid. If it's more than 7, then basically the pain will come in the joint. So let's check here the data analysis. ANOVA 2 factor with replication. Here is any replication. Can you see here? Here is only treatment. Here is a 3 levels treatment. So let's see again the dependent and independent variable. So hypothesis. Treatment 3 is more effective than treatment 1 and 2. This is the hypothesis. This is not a medicine, just apple cider vinegar with baking soda. So those treatment are more effective than treatment 1 and 2. Okay. So dependent variable, amount of uric acid, that's we tested. And independent variable, treatment 3 levels. Okay, now we will go here. So ANOVA 2 factor with replication. Here is a 2 factor. Here is only 1 factor. That's called a treatment under 3 levels. But another here is no any factor. Only patient. So here is a single factor ANOVA because here is only treatment is 1 factor. So we will go in the single factor. So here already selected and grouped by column and labels in the first. Here is a label because one here is a label only. Patient and treatment, this is the name. So labels in the first row and alpha 0.05 that are comparable with the significant effect and output range here. So you can see from here is the output range. It's okay. So okay, let's go. The analysis. ANOVA, single factor having trouble to offset input and output reference. Here is, so that's one need to select. Here is okay. So single factor here is analyzed. So we can see the ANOVA. So in the ANOVA here between group, here is p value is less than 0.05. So here we can see, but we can say the three different treatment here is a significantly effects on the uric acid by amount of uric acid. That means three different test or treatment has three different value or output or result, three different output. So another one, the conspicuity. So let's go another example. Bicycle accident with vehicle, that means car and bicycle accident has occurred due to the lack of visibility and conspicuity. Visibility means drivers cannot identify or cannot see on time, and also conspicuity, driver cannot recognized from the environment over there is any object as a bicycle. A driver looked on the direction but failed to detection as a hazards. So let's see here hypothesis. Reflective tape was applied in the bicycle frame that would be improved the visibility and conspicuity. So provide reflective tape was applied in the bicycle frame if that would be improved in the visibility and conspicuity basically at night. Okay, so dependent variable detection distance. Actually finally how you define that one, it will improve the visibility and conspicuity. So in that case the researcher already identified the detection distance. Okay, in the dependent variable, here is a dependent variable, so that's called the independent variable basically. Independent, that's on the independent variable. So independent variable here is a conspicuity treatment. There are 4 labels, and street light here is a 2 labels, that means street light off or on, and conspicuity treatment here is 1 they have defined already, the reflective tape applied. Another 3 conditions, the one is the control condition. So okay, let's see here the Excel form. So conditions, street light on and off, that condition, and here is the control bicycle. This is the 1 conspicuity treatment, that means no treatment here. This is the baseline study. And rear red reflector, we know the in bicycle here in the rear side here is a red reflector one for the night time visibility. And this is another conspicuity, here is high visibility jacket. This is another conspicuity, that means sometimes you can see the high visibility jacket, yellow jacket actually wearing by bicyclist. Another one is a reflective tape, that's researcher newly added this one. So they have tested by using detection distance from the car. So here is a different detection distance, control bicycle, this is the in meter, 150 meter, 80 meter, that's the detection distance. In the rear red reflector, in that case this is the detection distance, this is the detection distance, this is the detection distance. So here we can see by using data analysis. So here this is the replication, that means on, street light on, and here is off. So here is a replication test. So ANOVA 2 factor with the replication test. So let's see here. So we can select by using that this way, and here is a row per sample. So each row how many? 5. So sorry, here is a one problem, not equal here. Because here 2 to 4 here is only, so need to equal the value to analyze on the right way here. So in the street light here is now 5 and on and off now 5, so we can go now here. Sorry for mistake, that one. So again select the all, and a row per sample here is only 5. Street light on here is a 5 sample and off here is a 5 sample. So output range here, from here we can get output range. This the analysis. So here is a 2-factor with a replication test that we can get, and here is the ANOVA analysis that we can see the sample. At first the column here is a 4 treatment, because in the 4 treatment degree of freedom here is 3, and this is the significant effect. 4 treatment have a different detection distance. The mean value of 4 conspicuous treatment is different. So here is the significant effects on the detection distance. But here in the street light on and off, in that case 2 cases, one is the on, another one is the off. So here is the degree of freedom 1. So here is no any significant effects, because there is no any significantly different on and off condition in terms of detection distance. So here we can say that type of way, and here is the interaction, that's we can say also this way. So this is the very simple analysis to say any significant effects on the dependent variable. Basically the independent variable has any impact on the dependent variable, or is there any other factor behind that interplay between the two labels or two independent variable, that we can simply check by using data analysis. And same analysis I will give you with the SPSS and also R language. So please be in touch with me and share with your friends. Thank you for continue watching.